How could we figure out how much carbon dioxide is coming from the combustion of fossil fuels? The chemical reaction can help us do this. Chemical reaction gives us the exact relationship in terms of molecules. 2 molecules of octane are going to produce 16 molecules of carbon dioxide. These are exact relationships. We can also express this in terms of moles. 2 moles of octane are going to produce 16 moles of carbon dioxide. We just multiplied everything by Avogadro's number. So stoichiometry is a study of the numerical relationships between chemical quantities. If I start with 5 grams of octane, how many grams of carbon dioxide? That's a stoichiometry problem, looking at quantities in chemical reactions. Law of conservation of mass is definitely in effect here. These are chemical reactions, not nuclear reactions. The mass of substances you start with is equal to the mass of substances that you end up with. Atoms are not created or destroyed. And the equations are balanced by balancing the atoms, because it's the individual atoms being rearranged that cause the chemical reaction. The coefficients in that balanced chemical equation give us relative amounts of moles. And so we get conversion factors that are mole ratios directly from this balanced chemical equation. So we can say 2 molecules of octane react with 25 molecules of oxygen. We can say 2 moles of octane react with 25 moles of oxygen. And we can turn those into ratios or conversion factors. So for every 2 moles of octane, there will be 25 moles of oxygen used. Any questions? Abrupt switch here. Think about making pizza. Hope you guys had lunch. The number of pizzas you can make depends on the amount of ingredients you have, right? If you run out of crusts, you got to stop making pizza because it's not pizza without the crust. So here is a very simple recipe. 1 crust, 5 ounces of tomato sauce, 2 cups of cheese. That makes a pizza. We can express that mathematically. 1 crust to 5 ounces of sauce to 2 cups of cheese to 1 pizza. And we can use those ratios to figure out, well, what if we had 10 cups of cheese? How many pizzas could we make? Well, assuming you had enough of everything else. If you had 10 cups of cheese, you could not make more than 5 pizzas, right? We can do that sort of conversion in our head because we understand the relationship between cups of cheese and pizzas. But we really need to be able to write this out using dimensional analysis so that in the next step where we're doing carbon dioxide and octane, we don't get confused. So the way we would write this out is 10 cups of cheese. That's what we're given, and we're trying to figure out how many pizzas. So the unit pizzas and cups of cheese on the bottom, so that the units are going to work out. Everybody okay with that? We get one pizza from every 2 cups of cheese. That's this ratio, 2 cups of cheese to 1 pizza. That's a mole, well, not a mole ratio, but it's a ratio from the equation. 1 pizza for 2 cups of cheese. 10 times 1 divided by 2 tells us 5 pizzas. Same answer as what we did in our heads. Everybody okay with that? Ratios of the coefficients work as conversion factors in terms of moles. So moles of this to moles of that, the numbers come straight out of the balanced chemical equations. So let's go back to our octane burning reaction here. If we burn 22 moles of octane, how many moles of carbon dioxide form? This is the same process as the pizza and cheese question. Well, I have 22.0 moles of octane, C8H18. I want to know how many moles of carbon dioxide. So I'm going to multiply by moles of carbon dioxide and divide by moles of octane. It's important here to specify the formula. Because if you write times moles over moles, moles of what? It's very easy to get things upside down and backwards. The numbers for this ratio come from the equation. The equation tells me that 2 moles of octane are going to produce 16 moles of CO2. 2 moles of octane, 16 moles of CO2. I could simplify that, but I don't see the point. I might make a mistake when I did it, and that would be stupid. So I've got 22 times 16 divided by 2, and that comes out to be 176 moles of CO2. Any questions? What about sig figs? How many sig figs in those mole ratio numbers? Well, the first one has 3, because that's told to us 22.0 moles of octane, and that's a measurement, right? But this 16 and this 2, are those exact numbers? Yeah, they are. They're exact numbers because it takes exactly 2 of these molecules and exactly 25 of these to make exactly 16 molecules of CO2 and exactly 18 molecules of water, because none of the atoms are disappearing or being formed. So it's like building with Legos, right? If you start with 2 blue blocks, you end up with 2 blue blocks, regardless of where you put them in your thing. They're still there. So the mole ratio numbers are exact numbers. What that means for significant figures is that when we see a mole ratio, we can just skip over it when we're thinking about sig figs, because it cannot limit. So this is the only thing we're doing, so we start with 3, we end with 3. Any questions? I'll stop there.